Higher order derivatives are useful to apply to real life examples. In real life, we have things that have a position. Position is noted with an S of t. So tell me the time, and I could tell you S the position of any object. Velocity is denoted V of t, which is found by taking the first derivative of position. So the velocity is really how fast you're doing something, but it can be positive or negative depending upon the direction. Acceleration is an A of t. You can find it by doing the first derivative of velocity or the second derivative of position will give you acceleration. And we're going to talk about what these mean when we get into some real life problems. But these are all in reference to objects on a straight line. We want to remember straight lines can be horizontal or they could be vertical. One thing before we get into some possibilities is that speed is always positive because it's going to be the absolute value or the magnitude of the velocity. So when we talk about speed when we're driving, it's always a positive speed no matter our direction. So speed is the absolute value of velocity. It's always positive. So you would say you're driving 50 miles per hour, even if you're driving 50 miles per hour south, which would be a negative direction. So speed is just like velocity, but it's the absolute value of it. So some observations or properties that we get from this is, again, speed is always positive, whereas velocity can be positive or negative, depending on the direction that the object is traveling. So positive directions, if you're talking about a vertical line, would be up. That kind of makes sense to me that if you're on a vertical line and you want to have the positive direction, you'd be going up, whereas the negative direction would be going down. I always like the vertical lines a little bit better because they make more sense. So if you throw a ball up, the velocity would go from being positive when it's still going up in the air, but then eventually it would be a negative velocity because it's going to start coming down because of gravity. So the velocity will change sign, whereas the speed would always be positive because it's just the absolute value of your velocity. And then we also have these horizontal lines. So this, to me, I have to think about it a little bit more, kind of memorize it. So on the other hand, if we have a horizontal line, positive is not up, it's to the right or east. So right if we're talking left versus right, and east if we're talking about east versus west. And then negative is going to be the opposite of right, so it's left. Opposite of east is west. So with a vertical line, up or north would be positive, and down or south is negative. Whereas if it's that horizontal line, the right or the east is the positive direction. So something you can use to remember this is you made the right decision, you went to college on the East Coast. The negative choice would have been going to the left or the west. So one thing we can conclude then is that if we plug in a t anytime to velocity and it's bigger than 0, so bigger than 0 means it's positive. It means the object is either moving up or to the north, if it's a vertical line, or it could be right/east, if it's a horizontal line. We're just writing these conclusions all again, help you remember it. If you get a negative velocity, v of t is less than 0 for when you plug in a time. You must either be moving down, which is the same thing as south, or on a horizontal line, that means the object was moving to the left or the west. And then if your velocity is 0, thinking back to sign charts, If the velocity is 0, then you're just not moving. You're stationary. Which could be where the object is literally stopped, or it could be at the top or bottom of a soft peak. There was a derivative of 0, because remember that velocity is the derivative of position being 0. So it could just be at the top or bottom of a soft peak. Or, if we're talking about a biker going through the forest and maybe they had a negative velocity because they were biking left at 10 miles per hour, and then they stopped and they had a velocity of 0, that means they were just taking a break, and then maybe they went back and had a positive velocity because they biked back to where their car was by biking east or something like that. The last thing, and this is a pretty tough concept, when speed is increasing, is when the velocity and acceleration have the same sign. So if we made a sign chart with each of them, it would be where their signs matched. So they would both be negative, and then that speed is increasing, it's speeding up, because both velocity and acceleration are negative on that interval. Or if they're both positive, it would be speeding up, or speed is increasing. Slowing down would be when they had the opposite signs.